Hello grade 11s and welcome to the fifth segment of March test practice. Please take that down. Sorry about that. So, the opening statement for part 5 states, a physical sciences class sets up an experiment to investigate Newton's second law of motion. The net force acting on the trolley was increased by transferring mass pieces from the trolley to the hanging mass. The experiment was done 7 times, and the data collected is shown below. So we have readings 1 up to 7, hanging mass in grams, net force in newtons, as well as acceleration in meters per second squared. We'll come to the table later. For now on, let's just focus on the questions. So 5.1 asks, which law states that the acceleration caused by a non-zero net force acting on an object is directly proportional to the force and inversely proportional to the mass of the object? Remember, this is Newton's second law of motion. Okay, hope that is clear, and I hope that makes sense. .2 states, write down an investigative question for this experiment. So let's go back to the opening statement. A physical sciences class sets up an experiment to investigate Newton's second law of motion. The net force acting on the trolley was increased by transferring mass pieces. So they just kept on increasing the mass somehow, right? And then they wanted to see how this influences the net force, and they calculated the acceleration. So the main experiment were these two, right? Net force and acceleration. So a good investigative question would be, what is the relationship between the acceleration of the trolley and the net force exerted on it? Right? Hope that is clear, and I hope that makes sense. The good investigative question would be, what is the relationship between the acceleration of the trolley and the net force exerted on it or acting on it? 5.3 states, state one variable that should be kept constant during the experiment. So one variable that should be kept constant, we can say the frictional force of the surface. I know this sounds a bit obvious, but guess what? They need to do it on the same surface, or make sure that the surface has the same coefficient of kinetic friction. Okay. 5.4 states, write down the numerical values of D, E, M, N, X, and Y given in the table. So D, E, M, N, X, Y. Okay. D and E are in reading number 5, M and N are in reading number 6, X and Y reading number 7. Okay, so reading 1, hanging mass is 125 grams, net force is 1,05 newtons, acceleration is 0,6 meters per second squared. Now we need to find the relationship or the multiplication factor. Reading 2, we're going to say 250 divided by 2, 250 divided by 125, sorry, it's 2. Then let's try and multiply 1,05 by 2. Get 2,1, here it is, 0,6 times 2. 1, 2. Here it is. So here the multiplication factor is 2. Okay, so we go to D and E. We need to find the multiplication factor. 625, we're going to say 625 divided by 125. The multiplication factor is 5. So in order to get D, 1,05 times 5, 5,25 newtons. E, 0,6 times 5, 3. Okay, so E is 3 meters per second squared. M and N. We need to determine the hanging mass. We are given the net force. 7,35 divided by 1,05. 7. So the multiplication factor here is 7. Okay, my mistake. Then it's going to be 7 times 125. 875. That's M. 875 grams. N. 7 times 0,6. 4,2. 4,2 meters per second squared. X and Y. Then we are given that the acceleration is 6. 6 divided by 0,6. It's 10. The multiplication factor is 10. So 10 times 125. I'm getting 1,250 grams. That's X. Or 1,25 kilograms. And then Y. Here's Y. 10 times 1,05. 10,5. So Y is 10,5 newtons. I know that may have been a bit difficult, but you need to find the relationship between the variables that you are calculating. Okay? Hope that is clear and I hope that makes sense. 5.5 states, the track along which the trolley moves is correctly inclined to compensate for friction. If the track makes an angle of 10 degrees with the horizontal, calculate the coefficient of kinetic friction for the surface. So remember, the angle 10 degrees, so this is theta. Okay. I wish I could draw it for you, but that would take up my time. Forgive me. So what I need you to remember is that force of gravity parallel is equal to the kinetic frictional force. Okay. So FG parallel, remember it's mg sine theta. Fk, when you go to the formula sheet, it's mu k n. Right? N, the normal force, is equivalent to mg. So mg sine theta mu k times n times cos theta. My mistake. So n is mu k, n is mg, then you have cos theta. You cancel those that appear on both sides. M this side, goes. G this side, it goes. So you have, on the left you have sine theta is equal to, on the right, mu k cos theta. So mu k is sine theta over cos theta, which is sine 10 degrees over cos 10 degrees zero comma 1763 269807. So that's 0,18. Okay, hope that is clear and I hope that makes sense. I wish I could have drawn it for you to make you understand. So please forgive me. 5.6 states, plot a graph using the data from the table. So this is a graph of acceleration versus net force. When the acceleration is 1,05, the net force is 0,6. So when the acceleration is, oh sorry, I made a mistake. When the acceleration is 0,6, net force is 1,05. 0,6, 1,05. 1,2 goes along with 2,1. So somewhere here. 1,8 goes along with 3,15. So 2,4 goes with 4,2. Somewhere there. 3 goes hand in hand with 5,25. Somewhere here. And then 3,6 goes with 6,3. Then the last one, which is 4,2, will go along with 7,35. Oh my. So somewhere here. And then forgive me, I'm just going to join the points in a straight line. So your graph should look like that. Okay. Please note that the gradient is not the mass, but rather the gradient is the inverse of mass. Okay. I just ran out of space to ask those questions, so please forgive me. Alright. I know that was a bit challenging, especially 5.5, but I do hope that it will make sense the more you practice it. Okay. I just want to show you part 6 so that you can practice it before doing it. This is part 6. Please take it down. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.